In today's video, we're going to look at the life cycle of stars. It all starts with a big cloud of dust and gas, which we call a nebula. Over time, the attractive force of gravity pulls the dust and gas together to form a structure called a protostar. And as more and more particles collide and join the protostar, it gets bigger and bigger. And so its force of gravity gets even stronger, which allows it to attract ever more dust and gas. The gravity also squeezes the protostar itself, making it more and more dense. This means that the particles inside it collide with each other more often, which in turn raises the temperature of the protostar. Then, when the temperature and pressure get high enough, hydrogen nuclei start to fuse together to form helium nuclei, in a process called nuclear fusion. This gives out huge amounts of energy, which keeps the core of the star hot. And it's at this point that we call it an actual star, or more precisely, a main sequence star. While it's a main sequence star, the outward pressure, caused by all of that energy that's being released by nuclear fusion, is perfectly balanced by the inward pressure caused by gravity. This allows for a long, stable period that can last for billions of years. And it's this stage that our Sun is currently in. At some point, though, the star will start to run out of hydrogen, which, remember, is effectively its fuel. You don't need to worry about the details, but basically this means that the star won't be able to do any more nuclear fusion. And so the inward pressure of gravity takes over and contracts the star into a small ball, until it's so hot and dense that nuclear fusion can start up again, which will cause it to expand again. This time though, instead of just forming helium, the nuclear fusion will form heavier elements, including all the elements up to iron on the periodic table. Exactly how much the star expands depends on how big the initial star was. If it was a small to medium star, like our Sun, then it will form a red giant. But if it was a really big star, then it would form a red supergiant. Each of these two types complete the rest of their life cycles in different ways. So we're going to take a look at the red giant first, and then we'll come back to the red supergiant. After a relatively short time, the red giant becomes unstable, and expels its outer layers of dust and gas. This leaves behind a hot, dense, solid core, which doesn't do any nuclear fusion. We call this a white dwarf, because it gives off lots of light, so it appears white, and it's relatively small. Over time, the white dwarf gets cooler and darker as it emits all of its energy, until finally it transitions to a black dwarf, because it no longer has enough energy to emit light, and so appears dark. Now, if we whiz back to the two options for our main sequence star, the other possibility for the really big stars was to turn into a red supergiant. So let's now look at these. Red supergiants actually start to shine brightly again as they undergo even more nuclear fusion. After passing through several cycles of expansion and contraction though, they eventually explode in something called a supernova, which forms elements even heavier than iron that get ejected all across the universe. What happens next, again, depends on how big the star was. If it was just very big, then it will condense into a very dense core called a neutron star. However, if the star was absolutely massive, then it might collapse in on itself and become a black hole. The reason we call them black holes is because they're so dense that their gravity is able to pull in any light that passes nearby, which means that they literally appear as empty spaces, or tiny holes in the universe where no light is ever emitted. So to quickly recap everything, stars initially form from clouds of dust and gas that slowly come together under the attractive force of gravity to form a protostar. When the pressure and temperature get high enough, nuclear fusion takes off, and we transition to a main sequence star. After a long time, often billions of years, the star exhausts its hydrogen supplies and becomes either a red giant, if it's a small to medium size, or a red supergiant if it's a big star. The red giants throw off their outer layers to reveal a hot, dense core that we call a white dwarf, which then cools to become a black dwarf. Meanwhile, the red supergiant explodes in a supernova, ejecting heavy elements across the universe. And it then condenses into a neutron star if it was only pretty big, or into a black hole if it was truly massive. That's everything for today though, so if you enjoyed it, then please do give us a like and subscribe, and we'll see you again soon.